Alrighty, so this is the post office sells 1 cent stamps. Fill out the table below to show how much it would cost to buy different quantities of 1 cent stamps. So they give some examples. So one stamp equals so decimal equation, 1 times 1/100th, because it's 1 cent, equals 1/100th. Fraction equation is 1 times 1 over 100 equals 1 over 100, and the total cost, 1 cent. We have 2 times 1/100th equals 2/100ths. 2 times 100 equals 2 over 100. And that equals 2 cents. So let's see what 10 does. So 10 times 0, so 1/100th. Let's see here. You notice that the 1 and the 2 are the same. They just kind of shift how many spots? 1, 2 to the right. Right? So this is like dividing by 100. So this is going to be 10 cents, isn't it? Or 0.10, because my 1 went from the tens to 1, 2 to the, okay. And then we have 10 times 1 over 100, which is equal to 10 over 100. So that checks over here, which is going to be equal to 10 cents. All right, 20. That's double, right? That'd be 20 cents. And again, that makes sense, or 20/100ths. That makes sense that this is going from 20, shifting 2 spots to the right. So we have 20 times 1 over 100, which is equal to 20 over 100, which again checks with that, right? This is the same thing, which then equals 20 cents. Let's see, 45 stamps at 1 cent per stamp, or 1/100th. So that's going to give me 45/100ths. And now we have 45 times 1 over 100, which is equal to 45 over 100, which again gives us 45 cents. Ooh, 321 stamps times 0.01. So again, my digits are shifting 2 spots to the right. So my 3 is going to end up in my 1s column. And then I have 21 cents over, or 21/100, so 3 and 21/100ths. What does that look like multiplying by a fraction? Well, it's 321 times 100, which equals 321 over 100. Cool. Which is $3.21. And now we have 404 stamps. So it's that same thing that we're doing here. That's going to be 4 and 4/100ths. 404 times 1 over 100 equals 404 over 100. And that's going to give us $4.04. So again, in each problem, the numbers are shifting 2 spots to the right. We're checking it again with our 400, like this is a greater than 1, right? Because the numerator is greater than the denominator, and so our answer is going to be more than 1. And it's the exact same thing, right? So in decimal, the only difference between decimal and money is, at least with American money, we only have 2 spots to the right. And then we're going to add that number sign, or the dollar sign. So what do you notice about multiplying by 0.01? My numbers shift 2 spots to the right. You could also talk about the decimal point moving. I don't think that's the best way to go about doing it, however. All right, number 2, Amelia feeds her pet lizard crickets. The pet store sells crickets for 10 cents each. Fill out the table below to show how much it would cost to buy different quantities of crickets. They have your name here, Amelia. All right, so again, same setup, and it looks like we're using about the same number, so we'll be able to compare what it does when we're doing 10 cents. Oh, sorry, it's the same numbers as with 1 cent, or 10/100ths. All right, so let's do, so we got 10 times 0.10. And again, this one, they're shifting over 2 spots, or just 1 spot, right? So if I think of 10/10ths, that's going to give me 1 whole. All right, so that's 10 times 1/10. So check that out. It's 10 over 10, which is what? 1 whole. So that's going to be $1. All right, 20 crickets. That's double, right? So that's going to be 2. Both because the math works and because we're just shifting those digits 1 space to the right. We have 20 times 1/10, which gives us 20/10ths, which again is 2 because there's 2 groups of 10 in there. That's $2. About 45 crickets. times 10 hundredths, or 1/10. That's going to give us 4 and 50. Again, each of our digits shifting one spot to the right. Where's this 0 coming from? Well, that 0 is here. It's right to the right of the 5, isn't it? There's just a decimal point that we don't write, and infinite amount of zeros there. So that's going to be 45 times 1/10, which is going to give us 45 tenths, which again is $4.50. 321 crickets at 10 cents. Again, each digit shifting one spot to the right, so I'm going to go from hundreds. My 3 is going to go from the hundreds to the tens. So that's going to be 32 and 1/10, or I could put the tens there, I guess. Or the tenths, sorry. So 321 times 1/10 is going to give us 321 tenths, which again is another way to say this, 321 tenths. We wouldn't say that, but we could. And what money-wise, again, it's the same. It's $32.10. We would not need the 0 here. We could just say 32 and 1/10, talking about decimals, but money, we would have to put that 0 there. $32.10. And we have 404 crickets times 10 hundredths is going to give us 40 and 4 hundredths. Times 1/10, 404 tenths, which again, $40.04. Oops. $40.04. What do we notice about multiplying by 10 hundredths? Well, again, our numbers are shifting with that one spot to the right. All right. Here we go. Oops, that shouldn't be there. Patterns in multiplying by powers of 10. Alfonso's company sells t-shirts to soccer teams. Each t-shirt costs $10. Fill out the table below to show just how much it would cost to buy different quantities of t-shirts. Same numbers as we've been doing. Now let's see what this does. So we're just multiplying by 10. There's no fraction equation here because our number is greater than 1, I would imagine. So we have 10 times 10. That equals 100. 20 times 10 equals 200. I'm just going to kind of go down this way. 45 times 10 equals 450. Again, our numbers are shifting one spot to the left. And where does this 0 come from? Well, for 45, for 20, and for 10, for all whole numbers, 1, 2, all whole numbers, there is a decimal point and zeros that we don't write. That would just take too long. Inefficient. 321 times 10, all of my digits shifting one spot to the left, so that's 3,210. And 404 times 10 is going to give me 40. There we go. So total cost, that just, we put the dollar sign right to the left of our answer. So we have $100, $200, $450, $3,210, and $4,040. Again, we don't have to put the decimal point. We don't have to put the decimals there because it is a whole number. What do we notice about multiplying by 10? Again, if you talk about a 0 appearing or adding, I think you're going to get confused. Obviously, when we're multiplying by 10, there is just that number is shifting to the left and a 0 appears, but it's better to understand that 0 appears because there's a decimal point and a 0 to the right in the tenths, and that's what shows up there. Bye.